So friends, next concept is the template. Concept of template is similar to function. So similar way we can write it as a template. Now we have to keep the template class T, and here we can give this bracket. Okay. Now this T can be used to specify the variable. Now we can take any kind of variable. Okay, so we can take any kind of variable here, and while specifying here we can also write it as a tv. So whatever method or we're writing here, that can be used in similar way. Okay, so now this class is more useful. Okay, this class can be used for any kind of variable you want to use. So here it can be scalar or level or int or your float, any kind of variable you can use here. Now to call, to construct a variable of this kind, we can write it as the, this is the, suppose we are giving a name level. Similarly, we can specify that I want a scalar kind of the object. So let me construct more kind of the object. Okay, and let's print their values. We have written everything what we are going to need. So we are going to print these values. Now the constructor. Okay, so we have to do some modification in constructor. If you want to create a constructor of given type, so for the purpose we can write it here and we can paste it here. Okay, so we are also specifying the type of the argument we are passing here in the constructor also. Okay, so this is will be also the t, that is the type. Here also we can pass the argument that the this constructor is also the type T. So template name should be given here. Again, here we have to also specify that the class is of type T. Here also we have to give the class is type T. Okay, so this is the for the constructor. This is the another constructor, and this is the operator overloading. Okay, so everywhere we have to give the type name. Okay, now we have created three classes, n1, n2 and n3, and this is, here we are doing the operator overloading. Okay, now this operator overloading we are only specified of the similar kind. Okay, so here tr and tir, see, both ti and tr should be of a similar kind if you want to use this operator. Okay, so if you are going to add these two number, it is going to throw a error. Okay, so we can see, so let's compile and see what error it is showing. See, it is saying that missing template. Okay, so first we have to give the template here also, because this res is also a object of the same name. So here we should also give a template. Now again, let's run, compile. It is saying that no match for operator plus. So plus operator we have defined, because it is trying to add long int type and long double type. Okay, so this n1 and n2 have two different time. That is why it is not able to add these two number. Okay, so for this purpose we have to, maybe we can declare another variable of a similar kind, that is the scalar, and maybe we can name it as a n4. Let's change some numbers. Okay, now here we can say that add this n1 and n4. Okay, now we can compile this. So still some errors there. Okay, this should be n2 plus n4 because n1 is the level type and n4 is also scalar type. So we can add a similar kind of the complex number. So scalar and scalar we can do addition. So I hope there should be no error now. Okay, so it's compiled. Now we can put this. Okay, now you can see there, we can compare the result here. See, this n1 is the level type. Okay, so level, the decimal part is automatically removed. So you can see here that for n1 it is showing only the integer part. Similarly, n2 you can see it also shows the decimal part. Int also it removes the decimal part. You can see that here it has been removed. Now you can see that the addition of this n2 and n4. Okay, so you can easily see that we are getting the required result. Next topic is the inheritance. So this is very important topic, and I'm going to just copy the first example here, and I will explain you that why inheritance is required. So let me just copy this class 1 as the class 3. Okay, now we can do modification in class 3. Okay, so this is the same examples of here. Now sometimes what happens that some variables we are going to use in two classes. Okay, for example, here we are calculating the p. Maybe we can also calculate the Reynolds number in terms of the flow rate. Okay, so here also flow rate is required. Now here also we can calculate the Reynolds number using this flow rate. So this is the formula of the Reynolds number in terms of the flow rate. So here if you compare, two things are common. Okay, that is the mu and the q. Here also you can see that mu and q, in both terms it is the common. Okay, also we can see that the d is also there. Okay, so these things like q can be the member of these two functions. Okay, so in such situations we create first a base class, and then this base class can be derived into the other classes. So what I mean to say that, let me just create class fluid flow. So we can give a name class fluid flow, and now let's say take an example of protected. We have already given the examples of the public. Now take an example of the protected. So we can say mu. So we are giving one value, that is the mu. Now we can declare this flow rate. So to calculate the flow rate, we also going to need u, and this after mu we need this d, that is the time vector. So these things we are going to need. Now we we can create a function that is set values, where we will take the values scalar. Maybe we can take three arguments. Maybe we can take three arguments: scalar a, comma scalar b, comma scalar c. Now we can set these values, that is mu equal to a and u equal to b and d equal to c. So this values has been set. Now we can create the function that is the flow rate. Okay, because we are going to use this flow rate in both functions. Okay, that is the pressure calculated in Reynolds number. So those class are going to use this flow rate and these values mu, u and d. So here we can say that return, maybe I can copy this from here for it. Okay, so it is first calculating the area, that is the pow d square into e into area. So this will return the flow rate. Okay. Now we are going to derive this flow class into the pressure curve. We can derive it as a, we can derive it as the public fluid flow. Okay. So these things mu, u and d, it is no longer required here because we are not, we have already declared into the base class. So we have now set the length here. Okay, so we can call a function void set le length, and maybe take, we can take a scalar quantity of L and we can set length equal to L. Okay, so whatever the properties are mu, u, d and this flow rate, this has been called directly here. So this is the flow rate, this is the length, mu I have already declared, d we can set it. Okay, so this things we are just removing. Okay, so this is the one class we have created from the base class. Now another class we can create, that is the Reynolds number. So let me write here Reynolds num, that is public flow. Now here we don't no longer required anything because the formula is simple, 4q pi d mu. So there's no need of this. I can just say calculate RE, and this formula we can write here 4 into flow rate. This length is no longer required, pi into this d is needed, d into. Okay, so this is the calculation of the pressure curve and this is the calculation of the fluid flow. Now let me just remove everything. Okay, so this is the way of declaring the base class and the derived class. Now suppose we want to create a object for the pressure curve. So we just want to create a We are creating an object of the pressure class. Suppose I renamed this the pressure one. Now pressure one dot. There we first need to set the values of the mu d. So we can set the values of mu d equal to, maybe first mu is equal to 1.8 to the power minus 5. I can take 1 e to the power minus 5, comma. Second is the velocity. I can give it 1.2, comma. Third is the diameter. So 3 is to minus 3 I can give. So this values we have set. Now we can set the value as the length. If you want to use, so I can write pressure one dot set length. Now I have to give one scalar, so maybe we can give 20 centimeter. Okay, so this is the related to the pressure curve. Okay, so now we can similarly create the object of the Reynolds number. So maybe I can give a the RE1. Okay, so here also we have to set the values. So RE1, I'm taking the same examples. That is the 1 e to the minus 1.2 and a3 is to power 2. Now we can print the values here. Info, the pressure drop equal to. So I can call this object pressure 1, and from this I can call this method, that is the pressure well. So this method is going to give me the value. Okay, similarly I can calculate the Reynolds number. Okay, so this object we can call RE1, and the Reynolds function we can call here. So I can write it. Okay, so I think everything is good as far as now. Now let's just rename it class 3, and here in file we have to rename it. So that should be also class 3, and that should be also class 3. Now we can compile. Let's see 6 wclean.l wmax. So there are some syntax error that is expected. So here after class declaration there should be a semicolon. So these are the slightly mistakes. Semicolon I should not have forget. So as a programming coder, you should love this semicolon. So this is returning some value. That's why we have to write it as a scalar. So these things we should keep in mind. Mistakes we are doing. 70. So there is where it is. Okay. So here semicolon is required. So that is also syntax error. So the here this is capital R, and here we have declared the small r. Now it should run. There should be no any error as far as I know. Compiled. Now you can run this. You can see here that the Reynolds number is 360, and the pressure drop we have calculated is equal to 8.5. double three. So this is the concept of the inheritance. Inheritance is itself a very broad area. I'm not going to cover those things. The idea of inheritance is clear to you. Now let's see the polymorphism in C++. So to understand the polymorphism, let me just copy this CP class 3 again into the class 4. Okay, so this folder I am copying here. Now you can see there is class 4. We can rename it is class 4, and here also I can give class 4. Okay, going to understand this. See, there are two kind of the polymorphism are present in C++. First one is called as compile time polymorphism. Second one is called as runtime polymorphism. So in compile time polymorphism, there is another function overloading and there is another operator overloading. So operator overloading I have already explained. Okay, so polymorphism means there's a different form of something. For example, maybe you are doing PhD or MTech. So you are a scholar also, you are a student also, you are a son of a father also, you are a brother also. So you have a many form. So if function has many form or if operator has many form, that is called the polymorphism. So this operator overloading we have already seen. Now let's see function overloading. That is the compiled time polymorphism, and that is the concept of the virtual, that is the related to the runtime polymorphism. Okay, so for example, here we are calculating the flow rate. Okay, so let me take this example, set values. Okay, so I can put here int also, int here also, here we can give no any argument. So there are three kind of functions we are declaring in the base class, and maybe we can here give some values. Okay, now we can print the value also. Okay, city we will print u, and again diameter we will print d. Okay, so we created a function that is the set values by giving the different arguments. So here we are giving a kind of scalar argument, here we are giving the int argument, here we are giving a no any argument, and now we are going to create one object that is the of type fluid flow. Okay, so I am creating one variable, one object of the flow kind. Okay, maybe I have take f1. Now I can call this set values functions. I can call this set values functions by specifying any kind of this function. So we can call this function also, we can call this functions also, and it will show the result based on what you want to see. Okay, so for example, I'm calling this one function, first one. So I can write 1 e to the power minus 5 comma 2 comma c 1 e to the power minus 3. Okay, and now here I can call the function that is the f1 dot display. Okay, so it will display the values here. So maybe call, I can call this. So again I can just copy paste, and in second times we are taking just int values. We are giving just int values here in second argument. So maybe we can just give it 1, 2 and 1 here. And third one we are not giving any argument. Okay, so this is the related to the function overloading. Okay, now one thing remember here that this mu should be slightly lower. Okay, now let's compile this and see how this result will be to class 4 folder. So if I run class 4, so you can see here that, so starting from 1, this is the first function we have called. So you can see that this is the printing the same value. Second one, this is calling the int kind of, and you can see that it is printing the value. And last one, we have set some values by default. These are the values we have set. So it is the printing these values. Okay. So this is the function overloading. So based on our requirements, it is going to call, and this is called as the compile time polymorphism. Okay, so operator overloading I have already explained. Now let's understand what is the runtime polymorphism. So runtime polymorphism is something related to the base class and derived class. Okay. So first let me just turn off these things. Now suppose there is one function that is also defined in the base class and in the derived class also. For now, let me just turn off this Reynolds number thing. Now let's this display functions we are also going to define in the derived class also. Okay, so we can copy this and we can define this in the derived class also. So here there was no concept of the length. Now here we are also going to print the length here. So we can just copy it and we can write as the length, and this will be length value. Okay. So there is a slightly difference between the display function of the base class and this is the display function of the derived class. Let me create the pointer related to the base class. Remember, I told you that we can create a prime pointer of the class like this. Okay. Now let me create one object of this class. That is a derived class. Okay. Now I am going to store the address of this derived class in the base class. Okay. Now if I call, first let me call this set values for the P1, that is the derived class. So this values can I copy from here. Similarly, I can copy this value from here. So remember, this is the pointer of the fluid flow kind, and it is storing the address of the this pressure cal, that is a derived class. So we are going to call this display function using this ftr pointer. So let me explain again. So this is the pointer we are taking of kind of the base class. Now we have created one object of the derived class values, where we are storing the address of the derived class into the base pointer. Okay, now we have set the values, and let me call the display function using the pointer that is related to the base class. So let's see what result it is going to show. So we can see here that the compiler is calling the display function of this base class. Okay, so it is confused and it is calling the base function of the base class, even though we are storing the address of the derived class. So even though we are storing the address of the derived class in the pointer of the base class, so it is going to call the functions that is from the base class. So to avoid this, we can write here virtual. So we can write here a virtual. Okay, now when we have written the virtual code, virtual mode, so it is not going to call when you will create the derived class, and when you store the address of the derived class, then it is not going to call that virtual function, it is going to call the function which is written in the derived class. So now if we run, so now you can say here that it is calling these functions that is of the derived class. So you can see that it is also printing the length. Earlier there was no length. Okay, so this is how you can avoid the runtime overloading. So this virtual function is used while compiling the runtime overloading. So this is virtual function is being used to use the concept of the learn time polymorphism in the inheritance concept. Okay, so I hope this all the function and class concept is clear to you, and how this function and class concept is being used in OpenFOAM. In next tutorial I am going to give you one examples, and in that examples I will explain everything whatever I will explain in this basic class of the C++ concept. So please subscribe my channels and please share these videos to your friends. Soon I will be creating the videos that is the related to the C++ concepts using the OpenFOAM examples.